Às vezes, em dias de luz perfeita e exata, em que as coisas têm toda a realidade que podem ter, pergunto a mim próprio devagar, porque sequer atribuo eu beleza às coisas. Uma flor acaso tem beleza? Tem beleza acaso um fruto? Não. Tem cor e forma e existência apenas. A beleza é o nome de qualquer coisa que não existe, que eu dou às coisas em troca do agrado que me dão. Não significa nada. Então, por que digo eu das coisas são belas? Sim, mesmo a mim, que vivo só de viver, invisíveis, vêm ter comigo as mentiras dos homens perante as coisas que simplesmente existem. Que difícil ser próprio e não ver senão visível.
Beauty. Can you turn this up? No? Beauty is the name. To come close. Thank you. I start again. So, it's good now. Beauty is the name of something that doesn't exist. It's a sequence of Fernando Pessoa, which seems suitable to me to come closer to my way of thinking about architecture. So I translate what João said in the beginning. Sometimes, in days of perfect and precise light, when things possess all the reality they can have, I ask myself slowly why I even attribute beauty to things. Does a flower possess beauty? Does a fruit possess beauty? No. They've got color and they've got form, and existence only. So beauty is the name of something that does not exist. A name I give to things in exchange for the pleasure they give to me. It means nothing. But then, why do I say about things they're beautiful? Yes, even to me who lives, only to live, come the lie of man about things which simply exist. How difficult to be oneself and to see nothing else than the visible. So the search for beauty is what has brought me into architecture. When I started architecture at school, at university, the search for beauty was the reason for me to start. And at the time at university, the word beauty, it was not existing, it was not present, it was not available. But this was exactly why and what I wanted to find out, how to build a beautiful house, how to build a house that touches. Because beauty is the name of something that does not exist, I define my main interest in architecture to bring it to you closer. The first interest I call the optimal, minimal, and poetic space. The definition. With optimal, minimal, and poetic space, I mean that we should think architecture from the beginning of the space. Optimal, I define as optimal for the people, for the program. Minimum means to build adequately, pragmatic, economically, and not more than we really need. And poetic, it's just a dream. The definition, sizing, disposition, joining, and formal design of spaces is the main task of architecture. Architecture without space is not thinkable. Architectural work, it revolves around two poles, the body and the space. This means the forming of spaces and the design of the body which limit the space. The space in his unformed reality as a general void is something immaterial and has no visible expression in itself. In the most general meaning is architecture nothing more than the limit of the visible void. In the very moment when we take out a piece of the infinitely vast and unlimited space of nature and somehow surround it, it's not only a gesture. At this very moment, we already create architecture also in the widest sense. Here begins the active and intellectual engagement with the environment in its spatial bordering. It's a quote of Oswald Matthias Ung, a German architect who, let's say, researched very systematical about the space. The starting point for my space is geometrical, calm, clear, and orderly. I want to build quiet and not confused spaces. They should be simple, based on the present state of the technique. They should be warm and healthy. In between my thinking about my interests, in a very short summary, I will show some projects from the office. The first one is a house on the Hebridean island of Scotland in the UK. It's how can I start? You see here a drawing where you can already read the whole project. We call it analytic. The analytic is a drawing technique developed at the École des Beaux-Arts, where you have plans, sections, axonometric, and they all are composition. They have a relationship to each other. We have here section, the plan, section, elevations, axonometric elevation, axonometric drawing, and then we see the archipel of the Hebridean island. It's in the very west of Scotland, and you see a highlighted area. Here is the house. This is a section through this island. Here is the water. Then you go up, and here is the house situated. Now we zoom in. You see the bay. You see again the water in section and plan. And here is this little house for, let's say, a couple. And when I went there the first time, what I really liked about the place, it's like being on the moon. It's a very rocky landscape, and we could choose the site, and we choose a site which is at the same time high above. For one moment, I have to fix this here. Is a contradiction site, let's call it. In the same time, it's high above the ground and it's sunken. So you have a situation where you are in between the bay, the hills. You have different orientations, and you feel at the same time protected but totally free. This is a plan. The ground floor, you have a long wall dividing the ground floor in a private space in the north. The plan is north-south orientated, which is in the stones. And you have a very open dining area, which is the opposite of the north. It's very open to the south, and in the east you have a little garden connected to the kitchen. It's here. Then you can go up a little stair and you're in the first floor, which is defined by 2 columns, a fireplace, the stair, and you have a view on all of the 4 or 8 cardinals all around. And in a section you have a situation where you are 45 centimeters lower than these eaves, which are east-west orientated, so that the sun in the morning comes directly over the land to your place where you can have a coffee, or in the evening where you have a fireplace in the west. And at the same time, it's very small but very high. It's 6.5 meters high, and here you see the let's say the structure of the building, where you have you can understand it, or you have the wall, you have the main column in the ground floor, 2 columns in the top floor, the stair, and the corpus in the back. In a space, a piece of life is directed. A space can be like a backdrop for a work of art in which a piece of life is enacted. One can imagine here a society or a person who are enacted in a space in a given time frame in a stage play. Through this staging in real time, we can learn to respect life. Because one cannot describe the essential, its living just from the hint. This illusion evokes memories. Every space can be a known universe. We can think a beautiful space regardless of what happens in the next space, but starting from what would be nice at a certain time in the year, at a specific hour, at a very specific place. The basic question is how we want to spend our lives. Architecture is the backdrop to this. The essential factor are the cardinals, north, west, south, east, the light, the orientation in the space, the view, the atmosphere that should be in this space. Each space can be thought as a world of its own, as a separate universe. At the beginning of the space is a longing, a desire. In the beginning of a project is the imagination. It's a feeling, a dream, a desire, a wish. Out of this, the building develops. In a purely conceptual design, the project is developed by itself. A concept is a rule without poetry. The next interest I'm concerned about is, I call it the physical presence. With physical presence, I mean the strength of the bodies that surround us. Physical means corporal, presence means what is there or the strength of the presence. I talk about the boundaries that make up the space. These limits have to have a corporal strength. The basis for the physical in architecture, it lies in the material. Architecture is, if it's built, materialized. Each material has a unique regularity, a right and a wrong. We can choose to be against these laws and ignore them, or we can follow, listen to the material. I do not want to be misunderstood. For me, it's not a question about honest or dishonest construction, which is in self a total nonsense, because a construction is simply a construction and not more. My intention is that we should understand what the material it would like to be, and then to build with this knowledge physical present. Physical means that the surface is thought from the material that is behind. The surface is a result of the material as it is built, as it was thought, and it should not be scenographical. Architecture is simultaneously an act of the idea, the concept, and the construction. Not the poetic construction in the sense of a symbolic construction or a detailed story. It's about building with the material means to develop and to think details and the structure out of the material with simple, rational, mathematically logical conclusions. The next project I show very quickly, it's a hall in Switzerland. And again, we can see this analytic drawing with the 3 plans, the ground floor, the first floor, and the roof, a longitudinal section, the short section, 2 elevations. And we see here in each of these drawings a 1-to-1 detail. The drawing, it's 2 meters wide and 1.50 meters high. And here we see a section in 1-to-50. And with this kind of drawing, we want to re-evaluate the construction, that it's part of the architecture, and it's not separable. It's not possible to separate it from architecture. And to go to the project, here the main question was, in this, when you build a hall, the program normally is very heterogeneous. You have a lot of big spaces which don't fit together, and you get a little bit of addition of, it has a tendency to get a building which is an addition which is falling apart, let's say. So the main thing in this project was how to build a building which has, again, minimal spaces, which is compact and a clear volume, and in the situation. And so we have here the main hall. I just go into detail very on the surface. We have the entrance area here, a foyer, the hall, a stage, and the second stage. And we ordered the program that we get this kind of similar situation, that you have a stage on both sides. On the side you enter as the spectator, and on the side where the stage is situated. Then you go up, here you have storage, and so on. And we were thinking about the roof a lot. The roof is, maybe I go back to this part, is defined by this pre-stressed, prefabricated quarter shell concrete elements. So it's a quarter of a circle, prefabricated, and this element is over the whole building. You see it here in section. And how you put it in the height, it doesn't matter for this element, or either if you put it in which up or down. Of course, you have to think about the draining and but the whole, let's say the building here, you enter in the entrance part, which is at the lake, and here this vault is getting like a roof in front of the building, and in the hall itself it's generating an equal light, and you can divide this hall after functional requests into 2 or 3 halls. What is needed? Last one, it's a view backward to the, let's say, stage, and then on the lake of central Switzerland lake. If the surface is thought from the material that is behind, the surface will let us understand the construction retroactive. We see automatically we can make a conclusion. We live in a time in which for us it is predominantly not possible to understand how something is made. I think we should be able to understand this in principle, just intuitively, even if we are not a specialist, if we are a novice. The construction, it should be allowed to be as simple and unsophisticated and intuitively understandable, comprehensible, and logic, including the boundaries, the surfaces, the color, the material used. The way in which something is joined, it should suit to the material, it should be logic and pragmatic. I will show in the next project a remodeling of a late medieval house, and there we have dematerialized the material, the stairs, and also the roof space. They are abstract white surfaces. The bodies are physically present due to the geometry, the mass, and the life under the white color. Through the white concrete walls, the main idea of the building, of the double staircase and the labyrinthian system, it's strengthened. The project, it was not primarily about the material. I don't want to say that it's always a balance between the idea, the concept, the construction. So the project, it was not primarily about the material, but it was necessary to put an equally strong opponent to the existing strong substance. Nevertheless, of the abstract surfaces, the concrete, it was formed with rough timber boards, where you feel how it is done, where you can again make a conclusion how it is built, which were rough sawn, and the beams supporting the roof, they were made out of massive timber, which is 350 by 350 millimeter, which is massive wood. It's a conversion of a late medieval house in Stolz. It's not even a village, it's a hamlet. It has maybe 15 to 20 houses in Gießen, Switzerland. And so, what do we see? This little point is the village, and we see here all the plans, let's say, underground, entrance floor, first floor, the roof and the scheme, 2 sections and 2 elevations. And when I went there the first time, because it's a medieval house, protected and built over times and over times. There were living two families. It was, here we see it in section, the house is divided in the middle. It's as well used as one house as well as two houses for two families. And when we went there the first time, it was very labyrinthic with, 33 rooms, 9 types of stairs, and you almost got lost in this little house. And the main wish of the client was, let's say, to be able to live there again with two families, he and his father, and to solve the stair situation. And we saw this as a spatial quality, so we invented this double concrete stair, which is, let's say, symmetric. One is smaller, one is bigger, but you don't feel it when you are there. And this double spiral stair is connected at one point, so that again you have this labyrinthian system in this old house, but in one element, let's say, in this double stair. Another point what we reached by doing this is the typology of this house is a very special one. Normally in Graubünden you have houses with a big corridor, which is very special. It's a cold corridor. You could enter with a vehicle, really a big tractor or whatever. But in this typology we have we have almost 2 squares divided by 2 walls in the middle, and this repeats on each of the floors until the roof, where we opened this system in just a pillar dividing this space into the 4-room typology. And this is a picture of the construction site of this double spiral stair, and as I said, the house is protected, and I think we should go on building with these houses. We may do intervention which is strong. We may pour the concrete directly to the wooden beams which are 300-400 years old, and go on to make one, let's say, one house out of this. We may think our buildings for eternity. We may build impressive, monumental, durable buildings, not overpowering. I think we have built enough faceless, desireless, petty, backward-looking buildings around us. The presence must not restrict the proportion. The ratio to people is essential. It's a phenomenon. We travel thousands of miles to see buildings that we were meant for eternity, to admire them. We are dazzled by the beauty of old buildings. I think, for example, of the Pantheon, the Hagia Sophia, or the Temple of Hatshepsut. Can a building be a pure building that is just beautifully constructed? Architecture needs more than just the material-specific way of thinking. It also needs spiritual support to be able to exist over time. A building must not only have a material-specific way of thinking and a concept, but also an idea. It must be physically and mentally. My next interest, I will call it the interdependent totality. I want to explain to you my thoughts as followed. The definition. With interdependent totality, I mean the totality of all parts is complete and interdependent on each other. To be dependent on each other, it's a condition. To be a totality means to be unhurt, unharmed, and complete. Totality is understood as the combination of all components. This means, in the physical sense, integrity, actual determination, and perfection. If I talk about the totality that is interdependent, I have to demand that in my buildings there is an overriding whole, something that brings all together and where the most important parts are depending on each other. Just as the architecture is a whole, the drawing, this analytic drawing, it shows plans and surfaces which are depending on each other. Architecture is the art of space. Space in itself cannot be on exhibition. I explain this because how we came to this big, let's say, analytic drawing, which is 2 meters wide, 1.50 meters high, I told you. We were invited to take part in an exhibition in London, and were developing this drawing with the desire to be able to show a project in just one drawing. You know, this situation at the final presentation at school, for example, we have like, I don't know, 8 A0 plans, and we are losing the connection between the plans, and this kind of drawing is the try to have a density, to have everything connected to each other. We see here the school building in Thal, in Switzerland as well. We have 1, 2, 3 plans, the section for elevations, axonometric drawing. Here is the lake Bodensee called. Here is the little village of Buchen, part of Thal. And here is a 1-to-1 detail, which is 24 centimeter wide, and where, let's say, the starting point of the formal expression of the building is. The organization of the school and the necessity of the balconies. We see in section 3 floors, the entrance floor, the middle floor, and the top floor, and it was a competition, and there was a wish to use the corridor spaces in Switzerland. When you want to use the corridor spaces for school, you have the fire police, and out of these restrictions, we came to the architectural solution to do balconies. You can do technical solutions, but we wanted to do a spatial solution. So what you see here is a balcony layer around the whole building. Because of this, we are able to use always these spaces on each floor for exhibition, extra school, group rooms, and so on. And at this point, when we decided to do the balconies, I said I want to have a building which is depending in a constructive way also on each other. I didn't like the idea just to glue something, the balconies, in front of the building, so we developed a system where as well the outside structures or the outside columns and the inside columns, they are supporting as well in the cold as well in the warm part. Now in Switzerland this is a problem because we have this 24 or 30 centimeter insulation, and you cannot just build one wall anymore. This is something we have to solve. So this is a try to develop a building where as well the outer expression and the inner expression is understandable. We see here an axonometric drawing. This is the site. Here it's 3 meters high. Here is 0, so it's inclinated, and this reacts then to the building structure. We see here the inner supporting system and the outer supporting system extruded. You see 1, 2 pillars inside, a kind of a cantilevering wall, and then the outer element, which is here. And these two systems, they structurally supportingly come together. That the building is physically present and that a building should be a totality which is interdependent leads me to the thought about structure. If we imagine an arc, every stone gives the load to the next stone under it. Because all the stones want to fall down, at the same time, the arc is holding. The supporting structure and the spatial structure, they are identically. The supporting structure, it's a fundamental component of the architecture. Without thinking the supporting structure, it's not possible to think architecture. The nice thing is that there are very precise logical criteria of statics which make a form, which produce a form. It's an exact science. Most decisions in architecture are not an algorithm, are not clear and are not executable action rule, are nothing which leads to the result or are not very accurate. I think we should be grateful in this day and age that there is a right and a wrong again in architecture. We should use these precise logical criteria for architecture and not work against them. The interdependent totality is more than just supporting structure. It's also the circular system and the ordered classical spatial structure. The building can, regardless of the function and its permanence, create an outlasting element. If we think an outlasting urban element, which has taken a variety of functions throughout history that have no connection with his form, with his structure. The strong structure is not directly related to the program. We can differentiate between the first structure that makes up the building, the second, the third structure, which is flexible as far as it makes conceptual sense, which we can react to life. As I said, the project, it began from the one-to-one detail with the 24 centimeter insulation. We see it. Can you see it? It's here, the bright stripe. Here you see an iron part which is holding the window, and in between there is air or insulation. Of course, at the point where the inner and the outer system come together, it's not 24 centimeter anymore, it's 8 centimeter thin. Out of this very simple technical problem, we developed the building, which is in its appearance changing between filigranity and quite physical, present or massive spatial appearance. This is a construction site picture where you don't have the window inside and where you see the inner walls, which are going here to the column, and the outer thin column, which is connected to the balconies that you don't fall, to the balustrade that you don't fall down. And this inner wall at this point is as thin as possible, because where the wall cantilevers, it doesn't want to have load. And the opposite part, so here is one pillar, here are two, and the opposite part is a kind of a hanging concrete wall, and these two pillars, and in between the balconies, which are extra anti-supporting. If you imagine you pour it out of concrete, then it would work structurally as a beam which is above a wall, and that it's not working as a beam, we cut it out at the moment where it would touch the middle point where the pillar is on the warm side of the building. This is a scheme of the engineer. You see deformations of this spatial wall, how it is built and how it would be if we wouldn't have these two layers. So deformations would be higher. An interdependent totality is what remains and survives without losing its essential character. One can also mathematically say that the supporting structure, it lasts at least 50 to 100 years, and of course longer. It survives the facade, the building technology, which lasts 20 to 50 years, the program and the surface and the interior, which lasts about 5 to 10 years. This is a very important point. The totality, it should be perfect and imperfect at the same. Because if it's too perfect, it's getting inhuman. The claim that there is a greater whole which is interdependent, it itself leads to the question of the perfection. We adore the perfection because it is out of our reach. If we would reach it, we will reject it. The perfect is inhuman because the human is imperfect. It's a quote of Pessoa again. In order to achieve perfection, some kind of code would be necessary that is not human, but with it, the human heart would freeze, the heart that could love perfection. So perfection has something oppressive. A closed system, it doesn't leave air to breathe. That's why the fragment, the first, second structure, the break, is important. This is the east facade from the street, which shows the facade, which appears from the outside quite fine, filigrane, and then you see, so here these three columns. The inside column you don't see, it's hidden behind the glass, but I mean, you don't have to study about this building, but you believe it could hold. And the break in this facade is the entrance column, which is, in this system, it's not possible to have the entrance in the middle plus the column, because then you would just build something which is stupid in a way, or you go out and you run into the column. So it's inclined to the right side. This is the building seen from the back side. I said the topography, it's inclinated 3 meters high, and we see what the topography does with the structure, which is very rigid. It breaks at the point where the socle, the base, gets from a structure to a volume. And here you see the escape stairs, which are, we need to add to the balcony, of course, to that this fire system works. This is a picture in this balcony space where you have from outside it appears as a hanging thin wall. You have the escape stair coming down, and forms, they result out of functional and structural needs. Of course, they are controlled, but they are also appearing. I don't know how much time we have. Yeah, I do it very fast. I do a short excuse how it is done, because for me it's important that we don't have only ideas, but we should know what we afford, what we want, or yeah. So here you see the construction site picture, the outer shell and the inner shell, the pillar. This is a very technical section. This is the balcony area, the little column inside the wall going up, the insulation, which is here getting thinner, and this whole wall goes down, and here is the outside. How it is done, we build first this, the first formwork on the outer side. So then you put an Abschalig, so a formwork at the diagonal part, let's say. Here he already puts a technical element that the outer and the inner shell can come together. Here he glues the insulation is connected to the formwork. Then the reinforcement comes. We pour then in between these two layers. We close before, of course. Then we remove one side and we can pour against the inner wall where we see already the insulation, and piece which will be removed that the concrete can flow into the inner layer. In the beginning, of course, the school or the client, they were afraid that it's expensive, which was, it's quite the opposite, because we built very, the elements all the same, and when the construction company found out how to do it, it's like a normal wall. So here you see the inner wall without the formwork, then comes again insulation, and here you see a connection between these two systems, and already the part of the balcony, and this is a point of the building. We wanted to pour the edges to zero. You cannot build a material to zero. It will, or concrete, the smallest gravel is 32 millimeter. So we connected it together with the balcony part, and then you can do like a plastic. You can do like a sculpture, or you can do a edge which is going here to the 0 point, and you pour this part together and nothing breaks apart. In the end, when you remove the formwork, it looks like this. Here you see the inner and the outer shell, and this is a part of the middle wall. The break of the totality is something beautiful. So, as I said, in the beginning of the planning, first we are looking for a system which is clear, which has a perfection, and then we are looking forward to make it imperfect and human by finding natural given problems and to break the rigidity. As I said, examples are the diagonal pillar in the school in Thal, or the topography, which clashes with the structure, the escape stair, or in the remodeling in Stolz, the asymmetric pillar in the roof. A totality, it implicates the fragment. Only if you have something that is a wholeness, it's possible to have a fragment of it. The fragment, it lets us retroactive know something about the overriding whole. In the following, we will see a sequence of how it is to be in this school. So here there is a spatial phenomenon which I like a lot, because the process of learning, it has something to do with concentration and with open your mind. And especially when you are in this school, you have the moment you're very deep, surrounded by the concrete, by the walls, and the closer you come to the edges or to the middle, the space opens to the endless, gives you an endless view. So it's from narrow to wide depending on your position in the space. And this is a picture in the biggest space where you see the connection of the inner and the outer shell. Here we are at the highest point, it's going down to this 1 meter, going up and down, and on the outside the balconies. Each element has its own right to be there, let's say. Everything is built additive. The floors in the school, they are massive. It's 40 centimeter concrete as well. From, you see here the same material as on the top, which is this part. This is also one thing why it's built quite cheap, not cheap, but yeah, it's a primary building which is refined. Here you see a situation where the escape stair goes up and the forms, they kind of result in a controlled way. Here you are in the school, in the middle floor, we see this inclined column, and we know where we are because it's going to the middle, and here geometrically not. When we are one floor higher, it will match. From the inside, the outer structure is getting physically, it's a fragment of the whole system. This is a view in the corridor. Here is a detail of the not supporting wall, which is a slaried brick wall, one of the easiest things to build, and the earthquake wall, and the concrete wall, and each element has a defined dimension. The concrete wall needs to be 30 centimeters, the slaried brick wall needs to be 15 or 20 centimeters, demanding the acoustic requirements, and so they are built on both in the middle, let's say, and there evokes like an ornament or a gap of, not a gap, a Verschuere. This difference of 2.5 to 5 centimeters. The main stair in the building is not supporting. It's built out of 10 centimeter thin concrete walls to see also the difference. This is a part where we are in the topography. And what is interesting here is the more we are in the building, in the back, in the topography, each room appears different. This is a part in the middle room, and here is a detail how the inner concrete walls and the not supporting brick walls, they come together at the point where the program defines it. We need classrooms with 70 square meters. If it would be a little bit bigger, this wall would be at another point. It's not, it's kind of arbitrary. And this is the last picture I show you of the school, and then I'm almost finished, where the inner wall and the column comes together. So in my, and this is the last slide, in my judgment, architecture today, it's defined less by beauty than it is by ugliness. I'd like to end at this point with a conclusion of my motivation and my work. In my judgment, as I said, architecture today is defined less by beauty than it is by ugliness. And we should begin architecture with a longing, a desire, an idea. I think we got lost in the complexity of architecture. Architecture is the backdrop for a piece of life, for a society. When we build in a narrower sense, we build our life at the same time in the wider sense. We should take the physical boundaries seriously again. Most things we build make our environment not better, but worse. We live in a time in which it is predominantly not possible to understand how things are made. We should be able to understand how something is made intuitively. Construction is an underestimated and intrinsic part of architecture. But since we no longer build with our hands, construction has become indirect, remote, and alien. My work is an attempt to escape this alienation. The baseless separation of the idea and the execution, it degrades architecture. To create and to construct need to be inseparable. As architects, we have a great responsibility in society which we should take more seriously. Thank you.